All right, so today's talk slash meeting is not going to cover anything on the quiz that you're scheduled to take today. This is for in preparation, we're starting preparation for this coming Friday's quiz, lecture quiz number 3. We're starting a whole new system, the skeletal system, so it'll seem more relevant. Hopefully it'll be more interesting. But as I said earlier, it just gets more complicated. So every time we start a new system, expect a little bit more complication each time. So I suspect that lecture quiz number 3, which is coming up at the end of this week on Friday, will probably have a few more questions on it. It'll be not significantly, but it will be slightly longer just because there's more complicated stuff. All right, so let's get going. I'm going to dial up my first whiteboard here and just begin talking about the skeletal system. I'm not going to talk a lot about, nor am I going to ask you on quiz number 3 a lot about the different cartilages. We did that in connective tissue, but just to remind you, the 3 types of cartilage which you will be quizzed on today with lecture quiz number 2 are hyaline cartilage, which is the most common, elastic cartilage, which we find in the epiglottis and like the outer ear, and fibrocartilage, which we find like the knee meniscus and intervertebral discs. Those are all considered skeletal structures or part of the skeletal system. There's so much with the bones in the skeletal system that I'm not going to spend any more time on that whatsoever, unless it is relevant for me to mention in the context of, say, for example, later where I'm going to talk about how a growth plate works in a young person. And at that time, I will talk about hyaline cartilage a little bit. All right, so the first bit of business is the classification of the skeletal system. So there's anatomical divisions. Let me get my pen here. There's major anatomical divisions of the skeletal system. What we mean by that is there's basically 2 parts. So I'm going to put it number 2 here. And what we call the axial skeleton. And that is, think of everything on the center line of the body. That's what I'm just going to put. You could think midline, center line. So what's contained in the axial skeleton is the skull, the vertebral column, which you and I call the spine. That's sort of slang, but the skull, the vertebral column, and the rib cage. That's what's included in the axial skeleton. The second division, anatomical division, is called the appendicular skeleton. And that is just basically everything else. This word appendicular comes from the word appendage. So think of arms and legs mostly. So the appendicular skeleton is going to be the appendages, meaning arms, legs, hands and feet, and also the pectoral and pelvic girdles. That's just scientific language for what you and I call the shoulders and the hips. So axial skeleton, skull, vertebral column, rib cage. Appendicular skeleton, if you want to think of it as everything else, that's fine. That includes the appendicular skeleton, arms, legs, feet, hands, pectoral girdle, aka the shoulders, and the pelvic girdle, aka what you and I call the hips. Now, there's also classification of bones by shape. And there's just a little table in your book. This is really easy. We just classify bones. Your book, some books use 6 classifications. Yours just does 4. And this is just based on what they look like. Individual bones, what they look like. And it's really easy. There are long bones. I'll do it in the order of your book. Short bones, flat bones, And any bone that doesn't fall into 1, 2, or 3, typically we call an irregular bone. And you can guess what these look like. Obviously, long bones are long, short, flat, or flat. Irregular are just funky looking bones that don't fall into categories 1, 2, or 3. So there is a table in your book. I'm just going to quickly give you examples. Long bones would be usually bones in the arms and legs. So you could think like the humerus, which is the upper arm bone. You could pick the radius and the ulna, which are in the forearm. But I'm just going to write humerus and femur as examples. So arms and leg bones mostly. Also mostly the bones in the hands and the fingers are also considered long bones because they're longer than they are wide. Short bones are specifically things like bones of the wrist are called carpals. Bones of the ankles are called tarsals. These are typical short bones. There are also special sesamoid bones. I'm just going to add this one, the patella, which is the kneecap, as an example of a short bone. Flat bones, that just like they described, they are flat. I'll discuss what the anatomical arrangement is of the tissue later today, but examples of flat bones would be things like the sternum. You might know that as the breastbone, right in the center of your rib cage. The scapula or shoulder blade is an example of a flat bone. Also the cranial plates. Those are bones of the skull, mostly on top of your head and the sides of your head. Those are classic flat bones. Finally, irregular bones are funky looking bones that don't fall into categories 1, 2, or 3. Some quick examples would be the vertebrae in your backbones, in your vertebral column, and things like the pelvic bones. Those are kind of weird shaped. All right, so that's a quick classification by shape. This is all in your book, so you don't have to feel like you have to scribble this down as fast as I'm writing. This is just to help you picture things as I discuss them. So let's go on to a new whiteboard, and I'm not even going to write this business. I'm just going to say it. But the functions of the skeletal system, I'll just ask you 1 or 2 questions on the quiz about overall functions of the skeletal system. Run through these quickly. Support, the word support, what that means is it supports us internally, being able to stand up or sit up straight. Our skeletal system allows us to do that in conjunction, of course, with the muscular system. But support is the first one. Protection. The bones protect things like the rib cage protects our thoracic organs. Our skull protects our brain. So protection is a big one. Movement. That, once again, is in conjunction with the muscular system, but our muscles pull on our bones, allowing us to move our arms, our legs, walk, whatever. So movement is a big one. We've got support, protection, movement, mineral, lipid, storage. So what we're going to find out when we talk about the composition of bone is that our bones are the major storage site specifically for a mineral called calcium, which you probably know, which is, you might not know this, it's the most used mineral and ion in the human body. But calcium, things like magnesium, potassium are also stored in bones. And we also store fat in bones. Blood cell formation is the 5th function on the list. We did mention this when we talked about spongy bone and tissues, when we talked about the fluid connective tissue of blood and blood formation. I'll talk more about that. So blood cell formation occurs in the bones. And finally, there is some hormone production. Not a lot, but some. All right, so new whiteboard here. And I'm going to go to bone structure. First, I'll show you how a flat bone is structured. And then I will show you in more detail how a typical long bone is structured. So a flat bone, So for example, if we take the scapula, the shoulder blade, or one of our cranial plates from the skull, and we slice that open, it would look something like this. So this is a cross section of a flat bone. We have a covering sort of on the outside of this bone that is hard, compact bone. That is a very hard, dense tissue. And then on the inside of this bone, we find spongy bone. Those little tiny bone needles are spicules. So I'm just drawing that quickly. So a typical flat bone looks like this, with spongy bone on the inside and compact bone around the outside. And this has a sort of, it has a sandwich appearance, and that has a name. I believe it's French in derivation. This term, diploe, refers to the sandwich structure of a typical flat bone. And all it means is compact bone around the outside and spongy bone on the inside. And just to remind you, in the spaces of this spongy bone is red marrow, that gel-like structure where blood cells are formed. It's full of stem cells and blood capillaries. So I'm just drawing that real quickly. So there's a typical flat bone structure. You don't have to draw this. I'm just going to ask you a few questions about it, like what does diploe mean, that there's compact bone around spongy bone and a typical flat bone. So now I'm going to delete this and go to a new whiteboard. And do in more detail a typical long bone structure, okay? And I'm going to identify different specific individual structures within this. So I'm just going to quickly draw a generic long bone. Start over, that wasn't so good. I need to draw it a little thicker as well. So if this is a typical long bone, say the humerus, for example, the upper arm, there is compact bone that makes up most of this shaft of the long bone. There's a hollow center. Technically, it's not hollow, but there's a space, a cavity in the center. And this shaft of the long bone is called the diaphysis. This is a lot of this skeletal system business, and A&P in general, is learning the language. Diaphysis just means the bone shaft of a long bone. The end of a bone, of a long bone, is called the epiphysis. So it's not complicated or difficult to understand, it's just learning new words. So there would be another epiphysis down here. And if you hear me say things like the proximal epiphysis and the distal epiphysis, that just, I'm talking about the ends of the bones. Proximal would be closer to the body, distal would be further away. All right, so diaphysis means shaft, epiphysis means end of a typical long bone. The tissue, the bone tissue in the diaphysis right here is compact bone, hard and dense. Okay. Then that compact bone gets really thin in the epiphysis just around the outside, sort of forming a covering. And most of the epiphysis of a long bone is spongy bone, these little bone needles. So I'm going to draw that. So in your book, and as well as on quiz day, quiz 3, if I say what type of bone is in the epiphysis, it's spongy bone. I'll draw spongy bone down here in this epiphysis. What type of bone tissue is found in the diaphysis? That's compact bone. So let me label this And it would be the same down here, spongy. And then I'm going to fill in the space, not the whole thing, just to remind you that we find red marrow in spongy bone tissue. All right. Now, the space in the diaphysis, this cavity, is called the medullary cavity. So I'm going to label that. This anatomy of a typical long bone, I will expect you to know. The medullary cavity is found in the center of the diaphysis of our long bones. In an adult like you and me, people who are fully grown, inside of the medullary cavity, we store fat in here, lipid tissue, adipose tissue. So I'm using yellow to fill it in. And this is called yellow marrow. So yellow marrow is found in the adult medullary cavity. It's a storage place for us to store lipid or fat for energy reserves. As a matter of fact, when people are literally starving to death, that is the last place that your body goes to, one of the last places for energy storage to use. So it's an energy reserve. In an infant, that medullary cavity is filled with red marrow. So over here, I'm just going to write infant. It's a place of blood cell synthesis, red marrow in, I'm just going to put med cavity. So after we are babies and we start to grow and develop, the space goes from containing red marrow to yellow marrow. Now in an adult and in an infant, the epiphyses are all spongy bone with red marrow out here. So we do have our red marrow obviously as adults, but it's just not in the diaphysis medullary cavity. All right, so there's some basics. I'm not quite finished. Around the end of a typical long bone, on the outside of the bone, we find a covering of hyaline cartilage. It's called articular cartilage. I mentioned this when we studied hyaline cartilage in our last connective tissue unit. So I'm drawing this articular cartilage. I ran out of space down here. Oh, I can just squeeze it in. So what's in blue? Articular cartilage is hyaline cartilage tissue. That is found on the ends of long bones because that's where long bones articulate or come into contact with other bones at a joint. And this is a nice, this hyaline cartilage is a glassy smooth surface, and it provides for a nice glassy smooth surface so that bone tissue doesn't grind on other bone tissue. Almost there, almost finished. On the outside of this bone, on the diaphysis, that's what I'm trying to draw here in green, is sort of a covering, a jacket-like covering of coarse connective tissue. So if you were to take the bone out of my arm right now in a living person and look at it, it wouldn't be all clean and white. It would be covered with all sorts of tissue. And what wraps around the diaphysis of this long bone is a coarse connective tissue called the periosteum. Peri means around, osteum means bone. I'll talk about the functions of the periosteum later. We're just identifying anatomical structures of a typical long bone. Now, in an adult bone, like you and me, right below or in the area between the epiphysis and the diaphysis, so I'm going to draw a black line right here. This is called the metaphysis area, but this line that I'm drawing, we see on the outside of a typical adult bone. It's called the epiphyseal line. And I'm running out of space to write. So over here, I'm just going to write epi, ph, epiphyseal line. That is a scar or a remnant, and there would be another one down here, of where our growth plate was when we were young. When we're still growing physically, there's a space where I just drew this line that is really hyaline cartilage. It's what you and I call a growth plate. And then when we're finished growing, that hyaline cartilage seals up and meets bone on bone, and there's a remnant, a scar of where that growth plate was, called the epiphyseal line. So I'm just checking my list here to make sure I did diaphysis, epiphysis. The word metaphysis just refers to this space here between the epiphysis and diaphysis. Medullary cavity we did, yellow marrow, epiphyseal line. Epiphyseal plate, I will talk about that. That's a growth plate later. Now this periosteum, this connective tissue out here in green, it's actually attached to the bone with these little penetrating needles of connective tissue like this. It provides a route. One of its functions is it provides a route for arteries and veins to go into the bone tissue. So I'm going to draw a main artery going in through the periosteum and into the bone tissue. We call this main artery a nutrient artery, and it supplies the main blood supply to the bone tissue. Remember, bone is highly vascular. Unlike cartilage, which is highly avascular, bone has a lot of blood supply and a lot of nerve supply. So that nutrient artery is supplying blood to this bone tissue. The last thing, and I've run out of space, so I'm actually going to save this board, just pull up a new one. This word, I'll go to a black pen, sorry. So we did the periosteum. That is what is around the outside of the shaft of a typical long bone. It's also around the covering. It's also, I'm just going to put around the outside of a flat bone as well. So we find periosteal tissue around the shaft of a long bone and around the outside of a flat bone. This word, endosteum, which you can probably guess means inside. Peri means around the outside. Endo means within. So endosteum is, this is coarse, dense connective tissue. Endosteum is thin, delicate connective tissue that lines the inside of the medullary cavity. There's two L's in medullary. I always tell students this endosteal tissue is sort of like the lining of the inside of a soup can. It's super thin. It's a coating on the inside of the medullary cavity. That takes care of our language for now. So I'm going to talk some more about the periosteum, that dense, coarse connective tissue found on the outside of a typical diaphysis of a long bone, and list some major functions. First, it helps protect. So I'm going to write protection and isolation. It helps isolate bones from other tissue. Protection and isolates. It contains osteogenic cells which are stem cells, on the inner surface of this periosteum. So you don't have to draw this, but if this is the bone tissue and we used green, and this is the periosteal tissue on the outside of that bone, we find stem cells, I'll use yellow just for fun, on the inside of this periosteum. And stem cells continually divide and make new bone cells. Okay, we find them sort of on the inside of the periosteum. So back to major functions of the periosteum. It is rich in vascularization, so lots of blood vessels. It also has something called a nutrient foramina. Don't worry, it's not complicated, it's just new language. Foramen means whole, foramina means really small hole. So a nutrient foramina is just the place where the nutrient artery and nerves enter the bone. Okay. Almost finished with these functions of the periosteum. I do want you to know this term, Sharpies, and that's S-H-A-R-P-E-Y apostrophe S, Sharpies fibers. They are the collagen fibers. They're actually part of the periosteal tissue that penetrate the bone surface and hold it onto the bone tissue. So they're collagen fibers that penetrate bone surface. It would sort of be like if the jacket or hoodie you were wearing had a lot of tiny sharp needles on the inside of it sticking to your skin. So the Sharpies fibers, if this is the periosteum out here on the outside of the bone tissue, and the black is the bone tissue, Sharpies fibers actually do this. They stick into the surface of the bone tissue and hold the periosteum tissue tightly to the bone. All right, so let's move away from the periosteum, endosteum. I'm going to pull up a new board. And we're going to talk about red marrow very briefly. I talked something about it when we did bone as a connective tissue, spongy bone as a connective tissue. I'm just going to add some functions and some words. So this big word, you'll hear this again in AMP2. It's pronounced hematopoietic. I'll decipher it for you after I write it. Hematopoietic tissue. Hematopoiesis is just a long fancy word that means the formation or synthesis of blood cells. And so because blood cells are made or synthesized in red marrow, we call it hematopoietic tissue. So it is the site of blood cell synthesis. And we find this tissue, I've said this, I'm just writing it, found in the spaces of trabeculi, which are just the tiny bone needles of spongy bone. So we've defined, and I've drawn spongy bone for you several times. Those little bone needles have a scientific name. They're called trabeculi. And in the spaces between those trabeculi, we find red marrow, this hematopoietic blood cell synthesizing tissue. Now I'm going to flash something up for you. I do this every semester. You don't have to do this. It's just a recommendation. So let me get rid of this white screen. I usually photocopy a table from my textbook. So if you have the digital version, you can print this out. If you have the hard copy version, you can just photocopy this or scan it. This is a table from your book, table 6.1, and it lists all of the bone markings that you need to get to familiarize yourself with. I'll start reading some of them. You don't have to memorize them from straight off, all right? That's part of learning this business, is to just learn the language. And it is too much to expect you to just write out, memorize all of these terms. What bone markings mean, and you'll get to know most of these bone markings when you do the skeletal system lab assignments that are due next Sunday. So bone markings just refer to, I'm just going to, bumps, crevices, holes, protrusions. They are basically things on the surface of bones that we give names to. And I'm just going to give you some examples. Like the word tuberosity means a rounded projection that sticks out from a bone. Something like a crest would be a narrow ridge of a bone. The head of a bone refers to the end and expansion. Like the head of the humerus is this part up here. It looks like a head. That's an expansion above something we call the neck. Something like a foramen or foramen is just a hole through a bone. So these words are called bone markings, and it's just a list of language, a list of definitions. You don't have to do rote memorization and just know all of these off the top of your head. However, I do recommend either photocopying or printing out table 6.1 from your textbook, so that when you do all of your exercises, lab exercises for the skeletal system, it will really help you to have that handy. And I will just ask you a couple questions on quiz number 3, lecture quiz 3, about the language of defining some of those terms. So that was an announcement I needed to make during this meeting. Now we're going to go on to something called living cells of bone tissue. So you know that there are living cells in connective tissue as well as a non-living matrix in connective tissue. Bone is a connective tissue. So bone is made up of living cells and a non-living matrix. Now we're going to talk about the living cells in bone tissue. First, this prefix osteo means bone, okay? That's first and foremost. I'm just going to list the living cells in bone tissue, hopefully in the same order as your book. There's 5 total, so I'm going to start with number 1. We've already mentioned them. Osteogenic cells. Some books also list these as osteoprogenitor cells. It's just easier to say and write osteogenic cells, and that I think is more common anyway. These are stem cells. So when you see that term, just think stem cells. They continually divide like all stem cells. and give rise to new bone cells. So they give rise to different types of cells called osteoblasts. I'll be specific here. And bone lining cells. These osteogenic cells are found beneath the periosteum. So I'm just going to say found in periosteum, that thick, coarse connective tissue around the outside of a bone, and in the endosteum, that thin lining on the inside of the medullary cavity. So that's where we're making new cells, brand new from scratch, is in the periosteum and endosteum, and we lay those new cells down on the inside and the outside of a bone. Second bone cell type, osteoblasts. Since we mentioned that up here in osteogenic cells, I'll define that for you now. We know that the prefix osteo means bone. You know what blast means. It's an immature cell that secretes some sort of a non-living matrix or fiber. So osteoblast, let's define it. It's an immature bone cell that secretes something called osteoid, which is part of the non-living matrix of bone. It's the organic part of the non-living matrix. All right? I'll discuss what the contents of osteoid later in this chapter. When a bone cell, I'm just going to show, if this is an osteoblast, and it's a happy osteoblast, so I'm going to give it a happy face. When it's young, we call it a blast cell, an immature bone cell. It secretes this sort of soft, gooey matrix when it's young. It secretes this stuff called osteoid. Osteoid combines with minerals that we've ingested, like calcium, to get really hard. It hardens it like epoxy. It gets really hard. That's why bones are hard. When it surrounds itself with this secreted stuff, this matrix, it stops secreting, and we call it a mature bone cell or an osteocyte. So it secretes when it's young, and then after it surrounds itself, encases itself, it stops secreting, and we call it an osteocyte. And now it is a mature bone cell. And its job is to maintain the matrix around it. That maintains bone matrix. It communicates to other osteoblasts and other bone cells for bone remodeling. So I'm just going to write communicates to other bone cells for a process that we call bone remodeling. Some of these terms will be discussed in detail later. So that's 1, 2, 3. We just have to do 2 more. I'm not going to erase this board in case you want me to go back to it. I'm just going to layer a new board on top of it and write number 4. Bone lining cells, which we've mentioned. Let's now discuss really what they are. That's L-I-N-I-N-G. We know where they're located. Their shape is they're kind of flat. So they're flat cells. And they're found on the surface, underneath the periosteum, but found on the surface of bone. Where remodeling is not going on, not happening. They're a maintenance type of cell. They're also sometimes called periosteal cells because they're found, or endosteal cells because they're found but underneath the periosteum and the endosteum. Their main goal is to help maintain bone matrix. I got your message. So what this says is bone lining cells, flat cells found on the surface of bone. I should put a semicolon here, where remodeling is not going on. That's supposed to be an ON. And their goal, their real job is to maintain bone matrix. So they just maintain the environment of bone tissue. Finally, the last type of bone cell, living bone cell and bone tissue, is an osteoclast. Sounds like blast, but it's a C instead of a B. Osteoclast. And they're sort of like the opposite of osteoblasts. Always think of osteoblasts, immature bone cells. They make new bone tissue. They secrete new bone matrix, which makes new bone tissue. Osteoclasts do just about the opposite. They secrete enzymes, that's an and sign, and acids that dissolve and degrade bone tissue. I'm going to say bone matrix. So osteoclasts break down bone matrix. Osteoblasts with a B make or synthesize new bone matrix. These cells, osteoclasts, they are derived. They don't come from the osteogenic stem cells. They're derived from macrophages, which are immune cells, they were originally white blood cells, but they're immune cells. That's where they come from. They're the only living cell that doesn't come from those osteogenic stem cells. They are super large cells that are multinucleate. So I'm just going to give you that as a characteristic. That's M-U-L-T-I. Let me do a better spelling job here. It's difficult because this is such a slick surface. I'm on an iPad, writing on a vertical surface. Multinucleate. That just means they have more. The cells have more than one nucleus in them. I'll talk about bone remodeling in more and more detail as we go on, but why in the world would we want to dissolve or break down bone matrix? And the reason is because, one of the main reasons is because we store calcium in our bone matrix. And we need calcium in the body to perform all sorts of functions, life-sustaining functions. Every time your heart beats, it requires calcium. Every time your nerve cells fire an electrical impulse, that requires calcium. So all sorts of functions, major functions in the human body, require calcium. That's why we store so much of it in our bodies, in bone. We don't make calcium, we have to ingest it. So we store a lot of it in case we don't have a source to eat it. Now, the reason that osteoclasts, one of the reasons that they break bone matrix down, is to release that stored calcium. They unlock that stored calcium and release it into the blood so that it can be used. So that's important to wrap your head around. I'll mention that more and more often as we go on. So I'm going to describe to you compact bone tissue and how it's arranged. So I'm going to call up a new board. And just write structure of compact bone tissue. What that means is if we were to take a slice of that hard, dense bone that is found in the shaft of a long bone and look at it under a microscope, that's what we're doing here. So I'm going to erase this after I draw. Remember I drew a long bone like this. If I take a slice of that bone right through the center here, and I magnify that, so I take a slice of bone right here and magnify it and turn it on its end, that's what I'm drawing here. There's the medullary cavity in the middle of it. All of this stuff out here is hard bone tissue, and we're going to look at it under a microscope, okay? So just let me erase some of this so that I have room to write. Now we have this bone that we've sliced. This in here, if we're looking at an adult bone, the medullary cavity is filled with adipose tissue or yellow marrow. So I'm going to draw that in. If it were an infant, a newborn, it would be full of red marrow. But let's look at an adult bone. That's yellow marrow. I'll label that. Medullary cavity. I'm just going to put with yellow marrow. That gives you a frame of reference of what you're looking at. So we're looking at a bone. We don't need a microscope yet. Now what we want to look at though with the microscope is this hard tissue out here. And to you and me, when we look at bone, it just looks white. It looks plain, white, very boring and uninteresting. But if we look at it with a microscope, it's not just plain white tissue. What we see is that this hard tissue grows in sort of ring-like structures like this. These are not holes I'm drawing in the bone tissue. They're growth rings. And I'm not going to go all the way around the bone. It would take me too long. But what we see are these very faint ring-like structures, and they're called units of compact bone growth. So each one of these is a unit of bone growth, and there's a hole in the center, a small hole in the center of these units. My pen's giving me some trouble. And these holes run parallel to the medullary cavity, okay? We call these holes in the center of these growth rings the central canal. So I'll label that. And it's just a hole that runs parallel to the bone and parallel to the medullary cavity. So it would be running perpendicular to the screen here all the way through the bone. This growth unit is called an osteon. An osteon is a unit of bone growth. I'm going to say bone tissue growth in compact bone. Okay, so we have this is an osteon, this is another osteon, here's another one, and they all have a central canal running down the middle of them, okay? Now, within an osteon, I'm going to draw a really big one over here just because I need to draw smaller structures. Here's a giant osteon with its central canal. Inside of the central canal are blood vessels and nerves. So our blood vessels, our arteries and veins, and our nerves and bone tissue are literally running through these central canals. And they branch into smaller branches of vessels and nerves. But each of these, I'm going to enlarge this central canal. Each of these central canals contains vessels and nerves. Now, outside of that central canal, we have a pattern of these little tiny cavities, and they, in a ring-like structure. They're little cavities or caves where living bone cells live. And they sort of form rings around the central canal like this. Remember, the central canal contains blood vessels. That's where this tissue gets its nutrition. And that nutrition diffuses through these little tiny canals running to each cave that contains a living cell. So radiating out from the central canal and going from cave to cave are little tiny canals that allow nutrition to be transported to each of these. These isolated caves or cavities have a living bone cell in them. So this would be an osteocyte, which is a living bone cell in a lacuna. So I'm going to write the word lacuna over here. If there's an E at the end of it, that just means more than one. It's Lacuna, E if we're talking about more than one, just A if we're just talking about one. These are small caves or cavities where we find living bone cells. So cavities where living bone cells, I'm going to say, reside. And it's getting too small for me to, these little holes that I've drawn are lacunae. They're little pockets or cavities where we find living bone cells. And they're connected to each other via these tiny, tiny microscopic canals. They're called canaliculi. So I'm going to write that word. Canaliculi, A-E just means more than one. These are tiny canals connecting lacunae, one little cavity or pocket to another. And they help transport things like oxygen, nutrition, waste products, CO2, so transport nutrients and waste. So these canaliculi and this canal system is what connects our living bone cells to the source of nutrition, like blood vessels. This ring-like structure, when we look at it under a microscope, it looks like growth rings of a tree. So these osteons, these units, they tend to have these circular growth ring-like appearances when we look at them under a microscope. And what those are the actual living cells living in their little cavities or pockets. and they're connected by these little tiny canals called canaliculi. There's one more word that I want you to know in this structure of compact bone, but I'm running out of space. So I'm going to layer on another whiteboard just to write that extra word. And just so you know, it refers to, it's called lamella. I'll write this out, don't worry. Lamellae are, it sounds like lacunae, so it's easy to confuse it, but lamellae are actually the hard bone matrix that I've just put a dot on here. Out here, this hard white stuff between the living bone cells is what we call lamellae. So I'm going to go to a new whiteboard. Lamellae. This is the ring-like pattern of hard bone matrix. That's H-A-R-D, hard bone matrix. So quickly, I'll do this again. If this is just one osteon, this is not a full bone. Here's our central canal with arteries and veins. So I'll draw an artery, and I'll draw a vein. And now I'm going to draw, these are our lacunae, the little cavities around the central canal with living bone cells in them, osteocytes. Then our canaliculi help connect these caves or cavities. It helps connect these living cells to the outside world like this. And then this stuff, this hard white stuff that is actually once secreted and now maintained by osteocytes, by osteoblasts and osteocytes, that hard stuff, it grows in sort of ring-like patterns around, bone kind of grows like a candy cane, a Christmas candy cane, in sort of twisted ring-like hard material. And that's what I'm trying to signify here, is lamellae are actually, it's hard bone matrix that grows in a ring-like twisted pattern. Okay, we're almost finished for the day. I'm looking at my notes to make sure I got to where I wanted to be. The last thing, and this is a very short 5-minute discussion, I'm just going to, since we're talking about microscopic bone tissue, I'm going to erase this board and do one last business and I'll talk about spongy bone structure in detail tomorrow. But before we leave, I'm just going to write the chemical, since we're talking about microscopic bone tissue, I'm going to mention the chemical composition of bone tissue. And this is just a very short 5-minute discussion. So if I have an osteoblast here, it's an immature bone cell that secretes new bone matrix. So what it secretes is this stuff, this organic bone matrix called osteoid. The organic part of bone matrix secreted by osteoblasts. Okay, so that's step one. Within that osteoid, there are organic compounds. So the organic part of osteoids are collagen fibers. They're actually mixed in with the osteoid. Glycoproteins. And the other living component or organic component is the actual cell that is doing the secretion. So osteoid is made up of collagen fibers, glycoproteins. The word glyco just means sugar, and so we have a combination of sugary proteins. So we have collagen fibers, glycoproteins, and the living component of the cells that are sort of secreting this stuff. And then osteoid, that organic stuff, mixes with inorganic mineral salts. Things like calcium. There's other minerals in here, magnesium, but it's mostly predominantly calcium. This stuff, the inorganic mineral salts like calcium and magnesium, give bone its hardness. So when you ingest calcium in milk or foods that you eat, you absorb that in through your digestive system. It goes to your blood, and then your blood deposits this calcium for storage in our bones. And what that deposition, what that deposit means is this calcium that we have eaten, ingested, gets taken and deposited in combination with this osteoid mixture that this cell is secreting. And when osteoid mixes with calcium that we've ingested, I just wrote Ca++, that signifies a calcium ion, then it turns hard. So osteoid plus calcium gives us a hard matrix. It's a mixture. The last thing I'm going to say, if you want to screenshot this, that's fine. It's also being recorded, so no worries. Last bit of business about this chemical composition is this. I'm going to put a star next to this. I'll ask you a question on quiz 3 for certain about this. So we already know that calcium and other minerals give bone matrix, make it hard. Collagen fibers give bone flexibility. So you don't think that your bones are flexible, but really they are on a very small scale. If you have if I just draw a generic bone here that's in the human body, and we get some sort of trauma or impact on it, you bump something really hard, or you're in a car accident, whatever, that bone can bend a little bit to withstand some trauma, okay? But if the trauma is too much, you know that it breaks. But we do have some flexibility in our bones. And what gives bone flexibility are these collagen fibers that allow the bone to have be somewhat flexible. So I'm going to shut it down for today and close the meeting off and continue tomorrow at 9 a.m. I'll send the invitation out probably this evening. So real quickly, if you have any questions at all, I'm just going to delete this whiteboard and I'll wrap up this meeting. If you have any questions for me, just go ahead and fire away, unmute your microphone and ask. I'll sit here for a moment. Remember, just chime in if you have a question. Don't feel about it that you're interrupting me, but also remember, obviously the quiz number 2 is today, opens at noon. I will send out the invitation for tomorrow's meeting. I'll also post today's meeting on the Canvas page. So we should see each other tomorrow at 9. Let me tell you something. You guys are doing the right thing by showing up every day at 9. Not only are you hearing this thing as it happens, you're hearing this first, and you can review it as many times as you'd like. You also have opportunity to ask me any questions you'd like. And you're keeping yourself on task, on schedule. One of the hardest things about these online courses, in my opinion, students, they get off schedule, and it's easy to put this off. If you start putting this off, it becomes a disaster. It becomes a nightmare. We're moving 3 times as fast as a normal semester. So if you have the discipline, which you guys do, to show up every day and listen to these talks, it keeps you mentally on task as well as on schedule. So if you don't have any questions, I will see you tomorrow, and look for my posts. All right. Have a great day, guys, and good luck on quiz 2.
Thank you.
Bye.